Hello, welcome back to the Trusted Postgres channel. In this series, we are discussing the Ansible-based Postgres deployment tool called TPA. On the last episode in this series, we downloaded and installed TPA, also known as Trusted Postgres Architect, and its prerequisites. Then we ran the TPA exec setup and self-test commands to complete and verify the TPA installation. In this episode, we will configure and provision our first TPA cluster on Docker. Before going forward, you should download and install Docker since we will not be going over those steps specifically in this series, but we'll be provisioning Docker containers in this episode. First, let's open a terminal and run a couple of TPA exec commands to make sure everything still looks good with the installation. The first command will be the last command we used in the first episode of this series, the TPA exec self-test command. Okay, everything looks good there. The next command we want to use that I'll introduce is the TPA exec info command. And this just tells us that our branch is up to date with the main branch as we pulled from the GitHub repository and also the current version of TPA, which is TPA version 23.35. So now let's open up a browser and navigate to trustedpostgres.com. And then under the Trusted Postgres Architect section, we're going to click on the GitHub link. And then scroll down, click on the docs folder. Then in there, click on the SRC folder. And from here, we want to scroll down until we get to the TPA exec configure file. Click on that. Okay, now we want to copy out this TPA exec configure command. Paste it into our terminal. But before we hit enter, we want to add a couple of other options in here. Specifically the option to configure our cluster for using Docker containers and also a specific Docker image, which will be TPA / and let's select Rocky version 8. So now let's take a look at this configure command and break it down a bit. What this is telling us is that TPA exec is going to configure and create a new TPA cluster directory with the M1 architecture, and we're going to use Postgres version 14, the community version. We're also going to use a failover manager, rep manager, and two more options that I've added. That's going to be the Docker platform option and the OS image option. For this series, we're going to be using TPA's Rocky 8 image. Okay, now let's look at that directory and its contents. You'll notice that there's a commands directory, which we will ignore for now and later explore in this series in another episode. There's the config.yml file and also a symlink to the deploy.yml file under the M1 architecture. So now let's open up that config file. And we'll go through and note a few of these variables, not all of them, but we'll go through a few of them that are the most important to note. So as I mentioned before, we're going to use the M1 architecture. The name of our cluster is Speedy, which is also the name of the cluster directory. A couple of things to note here. The keyring backend is system, but what we want to do right here is we want to change this to legacy. If we don't, it might interfere with key rings that are already configured on your host system. So to prevent that, we change it from system to legacy. We can skip past this vault name here. One thing to note that we're using Docker, so TPA automatically wants to create a Docker network for us. Of course, its name is going to be Speedy as well. Skipping down here, we look at the failover manager set to rep manager. The Postgres flavor is set to PostgreSQL, which just tells us that we're using community Postgres. And it's going to be version 14. Of course, Python 3 is the preferred version, and you want to make sure you leave that volatile subscription set to true. Let's see, now scrolling down here a bit, we'll talk about this section in more detail. You'll see that we have our first variable, the locations variable, which, since we're keeping it simple in this series, we just have the one default main location. This location name is arbitrary and it can be really anything. In more advanced configurations, maybe you want this to be called Data Center 1 and have a second location called Data Center 2 for your backup and replica nodes. Below that, our instance defaults variables just tells us that the nodes listed below in our instances section will all be Docker containers and they'll be running Rocky Linux version 8. Then in our instances section, we have 3 nodes declared. The first is our primary Postgres node. The second is our replica. And the third is our barman backup node, which will also manage our cluster logs and serve as our witness node. Each node must have a unique name, a unique ID, and an assigned Docker IP address. The node names are randomly chosen but can be specifically assigned using another option in the configure command. You'll also note that the second and third nodes have an upstream variable, each set to the name of the primary node, which is where the streaming write-ahead logs for this cluster will originate from for disaster recovery. So let's change these node names to node names that make more sense to us. We'll just change the name here for the primary to primary 01 and change its backup to backup 01. The replica, similarly, we'll just change it to replica 01. And of course, its upstream name is going to change to primary 01. And then backup 01 for the backup node. And then change its upstream as well to primary 01. Okay. Double checking all of that. Make sure all of our node names are correct now. Okay. Now let's go ahead and move on to the provision step. We'll scroll down here, click on tpa-exec provision.md, and scroll past these steps and just copy out the provision command. Go back to our terminal and then paste that in. And remember that at this point you need to have Docker already installed and working for non-root use on your host system, and during this provisioning step TPA will take some time to pull down from its repository in Docker Hub the Rocky 8 image if this is the first time you're running provision, and it'll also create 3 containers with that image applied. Okay, that looks successful. We'll just do a quick Docker PS to make sure our 3 nodes are there, looking good. Backup 01, replica 01, and primary 01. Okay, that is the end of the provisioning step, and we will leave it at that. In the next episode, we will run the deploy command, which will download, install, and configure Community Postgres version 14, Rep Manager, and Barman on our provisioned Docker containers using TPA. We will then log into those containers and run some basic tests to verify the deployment, ensuring that physical streaming replication is working between our primary node and our replica and barman nodes as expected, including regularly scheduled barman backups. To help grow the Trusted Postgres community here on YouTube, please like and subscribe for more content. Also, if you're interested in being one of our customers or contractors, please register at trustedpostgres.com and we'll be in touch as soon as possible to schedule your first engagement. Until next time, have a productive and peaceful day.